All right, so today we are looking at change of base and solving simple exponential equations. So to start out, to refresh our memory, let's do some warm-up problems. All right, so convert to a logarithm. We're in the exponential form currently. So remember, when we're an exponential to a logarithmic, we're going to change these two places. And when we do that, our base here gets reduced to a subscript and we add the word log. So the log base 3 of 1/27 equals -3. All right, convert to an exponent. Remember, we switch our y and our x places. X becomes the exponent, the log goes away. So 5 squared equals 25. And we know that to be true. All right, evaluate the log of 7.3. We don't have a base here. Remember, anytime we don't have a base is our ninja 10, which is how our calculator thinks. So we just plug this into the calculator. So log button, 7.3 equals 0.8633228601. We're going to round to 3 decimal places, so 0.863. All right, that was a good quick reminder of what we did yesterday. All right, so solving with logarithms. So to solve with a logarithm, we look at it and we say, can we solve this the way that it is? Do you have any idea how to find out what x equals? Yeah, me neither. So we're going to convert this. So solve like it is. Solve like it is, if possible. If not, convert. Oh, so if I read an N, right? And T. If not, convert. All right, so let's convert this to exponential form. So exponential form, we're going to trade places. This becomes an exponent, log goes away. So x squared equals 121. And remember, to cancel out a squared, we can take the square root of both sides. So x equals 11. Now we also know that in our last unit on when we talked about solving the square roots, we learned that this should also be -11. But remember, from our last lesson, we said that our y and our b cannot be negative. And so this cannot be a negative number, our x. What you look here is our b, our base cannot be negative. So we cannot have a negative number in this case. X equals 11. All right, next, the log base 7 of x equals 1. Yeah, can't solve it that way. So let's change it to exponential form. Switch your places, log goes away, this becomes the exponent. So 7 to the first power equals x. Oh, hey, well, that's easy. X equals 7. Next, once again, I'm not sure exactly how to solve that, are you? So let's switch in places. Because the exponent, so 2 to the x power equals 32. All right, and this is just, some math. We could just keep multiplying 2 times 2 times 2 times 2 until we get it, and it's 2 to the 5th. So x equals 5, because 2 to the 5th equals 32. All right, next one. Once again, let's convert. Trade places. This becomes an exponent. Log goes away. 5 to the -2 power equals x. And we can solve this. Remember, flip it upside down to get this positive. So 1/5 squared equals x. So x equals 1/20. All right, evaluating reminder. We just did one like this. I have no base written here, so it's an understood base 10. So let's say the log of 47 in our calculator is 1.672. All right, so important to know this process, how we did this. Because the next thing is, what about logs that aren't base 10? So how do I solve this? The log base 27 of 8. I mean, we did in our last lesson, we converted these and we said equals x. So then I can switch in places and I'd say 27 to the x power equals 8. But does that get us any closer to the answer? Do you know how to find this? Yeah. Okay, so here is what we're going to do today is we're going to find out how we get an answer to this. All right, so the answer here is the change of base. There's a G, change of base formula. All right, and the change of base formula is the log of the tall over log of the small. All right, which means that for the log base A of B, we're going to plug it in as the log base 10. Remember, we're not writing a base. Log base 10 of B over the log base 10 of A. All right, so we just write log B over log A. All right, so log of the tall over log of the small. So let's practice a few of these. All right, so log base 4 of 7. So log of the tall, that's the 7, over log of the small, which is 4. And we plug this into our calculator. Judicious use of parentheses is probably appreciated here. So the log of 7 over log of 7. And for me, mine, I have to remember to close the parentheses. Mine looks just like this. Log on my calculator, 7. And then I have to remember to manually close the parentheses before I hit my little fraction button over the log of 4. And that equals 1.40, and it's 0.4036, so it's going to be 0.404. All right, let's look at this one. So the log of the tall, log of 200 over log of 0.5. Again, parentheses, super important. Log of 200, close parentheses, divided by log of 0.5 equals negative 7.64, and it's 0.6438, so it's going to be 0.644. All right, is this any different if we have a fraction? Nope, we just need extra parentheses. So the log of 1/10 divided by the log of 5. Is negative 1.40.431. All right, let me write this because I didn't write this one down. Log of 1/10. You make sure you put that in parentheses when it's in your calculator over the log of 5. All right, and once again, I'm doing this on a Casio calculator. The TIs, if you're using one, may be slightly different. All right, so how to solve equations like this? 5 to the x power equals 2. Yeah, how in the world did we do that? All right, so let's see. Step 1 is get the exponential piece by itself. Exponential. 2, rewrite. Step 3, solve. And solving is probably going to be using the change of base formula. That's the log of the tall over the log of the small that we just learned. Let me clean this up. That says gex. It should say get. There we go. All right, so let's look. Number 1. All right, the exponential piece is by itself. I can't do anything with that x up in the air, so let's rewrite this as a log. So once again, when we rewrite it as a log, we switch these places. This reduces to a subscript. We add the word log. So log base 2 of 9 equals x. All right, once again, I can't solve this, so I'm going to rewrite it as a log over the tall over the log over the small. So log of 9 over the log of 2, log of tall over log of small. equals x, and then I can plug that into my calculator. So the log of 9, close parentheses, divided by the log of 2, close parentheses, equals 3.170 equals x. All right, one more time. Exponential pieces by itself. So now I need to rewrite, switch places. This is a subscript. Log base 5 of 19 equals x. Log of the tall divided by log of the small equals x. So the log of 19, close parentheses, divided by log of 5, close parentheses, equals 1.829 equals x. All right, now look at this one. Next, our first step is to get the exponential piece by itself. Is it by itself? Nope. Okay, so let's do our first step. We're going to add 4 to both sides, and 13 and 4 is 17. So 3 to the x power equals 17. Once again, trade these places. This becomes a subscript. So the log base 3, 17 equals x. All right, change the base formula. Log of the tall over log of the small. So log of 17 over the log of 3 equals x. Employ your calculator here. Log of 17, close parentheses, divided by log of 3, close parentheses, equals 2.579. All right, seeing the process here? Get it by itself. Let's look at one more problem here. All right, because this is the most complicated one we have on here. So we need to get the exponential piece by itself. So first we're going to subtract 3. So 2 times 3 to the x power equals 10. And I need to divide both sides by 2. So that gives me 3 to the x power equals 5. Rewrite this as a log. Switch places, becomes a subscript. So the log base 3 of 5 equals x. Change the base formula. Log of the tall over log of the small equals x, and then calculator. So the log of 5, close parentheses, divided by the log of 3, close parentheses, equals 1.465. Remember to round to 3 decimal places. All right. Note, super duper important, don't multiply the bases. All right, so for this one, up here, we had 2 times 3 to the x power. We are not allowed to multiply these two together. All right, they don't have the same base. I can't say this is 6 to the x power. No, that is absolutely wrong. Okay, you can't multiply the bases. Remember, back to our exponential rules. You can only combine them if they have the same base. All right, so just like we would say x times x, and we can do that. And we can say y times y, and that we can do that. So this is x squared, this is y squared. But what if I say x times y? That doesn't, these two don't multiply together. They just sit there next to each other. All right, same way with this. I've got 2, I've got a 3. They are not the same base. You cannot multiply them together. So just leave them alone. We're going to, in this case, we're going to divide out that 2. That way we have our exponential piece by itself. All right, and that is really all there is to it. So if you have any questions, be sure you send me an email, and we will catch you next time. All right, I hope you all have a great day. Bye.